Okay, so we're going to move on to section 2.5, which is called equations of lines and linear models. So there's three different ways that we could write an equation of a line, three standard ways. One way is called point slope form. And the equation for this is y minus y1 is equal to m times x minus x1, where our point is going to be x1 comma y1, and then our slope is always m. Now sometimes people get confused with this. Sometimes they put the x and the y's in the wrong spot. So let me show you a way that we can remember this. Remember the equation for slope, it's just y minus y1, or you subtract the y values over you subtract the x's, right? That's the equation for slope. Well, if you want to get rid of the denominator, we've talked about this before, you can multiply by that denominator and it'll go away. Multiply by the denominator and it'll go away. And actually you'll wind up with point slope form. So just try to remember y minus y1 is equal to m times x minus x1. Another form is called slope-intercept form. And we've talked about this. We know that y is equal to mx plus b, where m is our slope and b is our y-intercept. And then the last one is standard form. And standard form we talked about also. Sometimes it's called general form, but very, very rarely. We are going to use ax plus by is equal to c. Now sometimes this is called general form, just so you know. And sometimes it's written ax plus by plus c is equal to 0. Now, I've only seen that a handful of times. In this class, we'll use the way that I told you up here. A few things I just want to point out. One thing is that a, the leading coefficient, is always positive. If it's negative, you could just multiply the whole equation by -1, and that would take care of that. Second thing is we're not allowed fractions, so let's say no fractions, or decimals. And for our equations to be in standard form, we want the x and the y on the same side. So the x always comes first. Those three things get you in standard form. So let's do some practice. Write the equation of a line through the point -4, 1 with a slope is equal to -3. Okay, well, let's do it in three different ways. We have our slope, we have a point, so maybe point slope form would be easiest. Now with point slope form, remember it's y minus y1 is equal to m times x minus x1. So it's going to be y minus our y1 value. Y minus 1 is equal to our slope times x minus -4. That would be point slope form. Now if we had to write it in slope-intercept form, one thing we could do is we could take point slope and rearrange it. We can just get the y by itself, or we could solve for it. So watch, I'll show you two different ways to do it. One way to get slope-intercept form is take our point slope, distribute the -3, and add 1 on both sides. So we get y is equal to -3x minus 12 plus 1 gives us y is equal to -3x minus 11. Another way we could do this, remember slope-intercept form is y is equal to mx plus b. Well, we have a y value from our point. We have a slope of -3. We have an x value from our point. The only thing we don't have is a b, or a y-intercept, which we could easily solve for. This would be 1 is equal to 12, and if we just use basic algebra, subtract the 12 on both sides, you'd get that b is equal to -11. So to tie it together, our slope and our y-intercept, you could see we get the same answer no matter which way we do it. I prefer the second way, but there's always, maybe 20% of the class that likes the first way better. And then the last form, let's get it in standard form. Now you can't just go from a point and a slope to standard form. You have to take one of the other forms and rearrange it. So we could take point slope, we could take slope intercept, it doesn't matter. Let's just take y is equal to -3x minus 11. We want the x and the y on the same side, so I'm going to add 3x to both sides. And I get 3x plus y is equal to -11. And that's standard form. A is positive. There's no fractions or decimals. And x and y are on the same side, so that's how we do a problem like that. I showed you 3 different forms. Let's do the same thing, but what if I asked you to write the equation of a line through -3, 2 and to -4. Now what makes this one different is we don't have a slope. We use slope for all the different forms. So let's go ahead and figure out what our slope is first. Going to subtract the y's in this order. I'm going to put that over the x's, subtracted in the same order. And I get my slope is -6 over 5. All right, and let's go through what we did before. As far as our point slope form, we are going to say y minus y1 is equal to m times x minus x1. Well, we have 2 points, right? We only need one, so pick whatever one you like better. This one is kind of standing out to me. So we have an x1 value and we have a y1 value. So we get y minus y1 is equal to m times x minus -3. That's a perfectly acceptable answer. Now what if you chose the other point? Y minus -4 is equal to m times x minus 2. It's totally fine too, right? So it doesn't matter which point you pick. If you rearrange this, either one, you would get the same slope-intercept form and the same standard form. Now for slope-intercept, we could rearrange them if you want. I'm going to do what most students do, and they solve for the y-intercept. So then let's use the point -3, 2. So I'll plug in -3 for the x value, -6/5 for our slope, and then 2 for the y value. Now we just have to solve for the y-intercept. So we get 2 is equal to 18/5 plus b. Now 2 is really just the same thing as 10 over 5. So 10 over 5 minus 18 over 5 gives us a y-intercept of -8 over 5. So in slope-intercept form, we would have y is equal to -6/5 x minus 8/5. Now, one other way we could do this is, instead of doing slope-intercept form by plugging in numbers and solving for the y-intercept, we could also just take one of our point-slope equations and just rearrange it. And if we add 2 and distribute the negative 6/5, we'd get y is equal to negative 6/5 x minus 18/5 plus 2, or plus 10/5. So you can see we get exactly the same answer that we got before. I just showed you a couple different ways to do it. And then finally, we'll get this in standard form. Standard form, remember, was ax plus by equals c. And usually we just take a slope-intercept equation and rearrange it. So let's go ahead and do that. We'll take y is equal to negative 6/5 x minus 8/5. First thing we could do is get rid of the fractions. We do that by multiplying by our LCD of 5. So we get 5y is equal to negative 6x minus 8. And then we could get the x on the same side with the y, and the x always comes first. 6x plus 5y would equal negative 8. Now the c value could be negative, but a has to be positive, there's no fractions or decimals, and the x and y are together. Let's move on to the next type of example. What if I asked you to find the slope and y-intercept of 4x minus 3y is equal to negative 10. Now, if you remember, we did learn a shortcut on this. We said that in general, if we have an equation in standard form, which is what this is, we rearrange this so we get slope-intercept form. We'd get that y is equal to negative a over b x plus c over b. So if you could remember that, I mean, just looking at this, we know what our a is, this is our b, and this is our c. So I could tell you that right off the bat, our slope would be the opposite of a over b, negative 4 over negative 3, which is 4/3. And our y-intercept would be c over b, c over b. So that's pretty easy. But if you'd rather not memorize things, that's okay. We could just take our standard equation and convert it to slope-intercept form. So let's bring the 4x on the other side. And we get negative 3y is equal to negative 4x minus 10. Divide everything by negative 3. And it's not a big deal. We get the same answer. Y would equal 4/3, x plus 10/3, and you could see our slope and our y-intercept are exactly the same as we already found. Let's move on to parallel and perpendicular lines. Now, parallel lines look like this. Most teachers teach it like railroad tracks. And in order for lines to be parallel, they need to have the same slope. We also have what are called perpendicular lines. Now, perpendicular lines look like an upside down T, or I mean, they could be a T like this. I mean, bottom line is they cross at a right angle. And in order to get perpendicular lines, we need two things. We need a slope that is opposite, and the second thing is they need to be reciprocal. And remember, that word reciprocal just means that we switch the top and bottom of the fraction. So for example, if one line had a slope of 1/3, the other line would have to have a slope. Okay, so take the opposite sign, that's a positive number, 1/3. So this is going to be a negative number, and then switch the top and bottom. Those two lines would cross at a right angle. So now let's do a problem like this. Let's say we're going to write the equation of a line passing through three, 5, and we'll do two parts. Part 1 is it's going to be parallel to the line 2x plus 5y equals 4. And then part B, it's going to be perpendicular to the same line. So we'll do it one step at a time. Well, if it's going to be parallel, we said that they have to have the same slope, right? We already have a point, we just need a slope. So you could use the shortcut I taught you, negative a over b, or you could just rearrange this if you want. And we get 5y is equal to negative 2x plus 4. We divide both sides by 5. We get y is equal to negative 2/5 x plus 4/5. So our slope would be negative 2/5. And because we want to write an equation parallel, we're going to use a parallel slope, which is the same thing. So we have a parallel slope and we have a point. So now we could go ahead and write the equation of a line. Now we have three different ways to do that, right? So using our point-slope way, which was y minus y1 is equal to m times x minus x1. We could use y minus 5 is equal to our slope times x minus x1. That's a perfect equation that's parallel to what was given. For slope-intercept, we could solve for b if you want, or we could just rearrange point-slope, whatever you want to do. Generally, people solve for b. So we would get the y value of our point is equal to our slope times 3 plus b. So 5 would equal negative 6/5 plus b. 5 is the same thing as 25/5. So 25/5 plus 6/5 is 31/5. So another equation in slope-intercept would be y is equal to negative 6/5 x plus 31/5. And then finally, standard form, we could just take our slope-intercept form and rearrange it. Let's bring the x on the other side here. That's going to be 6/5 x plus y is equal to 31/5. So a is positive, but we do have fractions, so let's take care of that by multiplying everything by 5. So we get 6x plus 5y is equal to 31. And that's if the line was parallel, right? So last step that we'll do to finish up this section is let's talk about perpendicular. So what if I asked you to write the equation of the line that passes through 3, 5, but I want it to now be perpendicular to the equation 2x plus 5y is equal to 4. Well, we already figured out what the slope of this line was. We already said that the slope of this line was negative 2/5, but that's not what we want to use if it's perpendicular, right? That would be a parallel slope if we use the same one. So to get a perpendicular slope, we have to take the opposite. So the opposite of a negative 2/5 is positive 2/5, and then take the reciprocal. So 5/2 would be our perpendicular slope. We're going to do the same thing that we just did. So let's write an equation in point-slope form. Let's write an equation in slope-intercept. And then we'll finish with writing an equation in standard form. So in point-slope, remember we're going to use this as our slope, but we're going to use the 0.3/5. That's what was given. So point-slope, we're going to have y minus y1 is equal to m times x minus x1. slope-intercept, we'll have y is equal to mx plus b. The y value is equal to the slope times the x value plus b. So we get 5 is equal to 15 halves plus b. And 5 is really 10 halves. So if we're going to subtract 15 halves on both sides, 10 halves minus 15 halves is negative 5 halves. So in slope-intercept, our equation would be y is equal to 5 halves x minus 5 halves. So that's kind of interesting. We have the same slope and the y-intercept. Let's just make sure I did that right. 15, 5 is really 10. 10 minus 15 halves is negative 5. Yep. And then as far as the standard equation, we could take our slope-intercept and just rearrange it. So I'll get the x and the y together. So we get negative 5 halves x plus y is equal to negative 5 halves. We want to get rid of fractions. Our LCD is 2. But if we actually multiply by negative 2, we would get a positive a value. So this would be 5x minus 2y is equal to 5. That would be our equation in standard form. Stay tuned for the next lesson.